Bismillahirrahmanirrahim. Assalamu alaikum student. I hope all of you are fine. Today we are going to discuss an important topic of how to find inverse of a given function, and that is exercise 1.2 question number 2. Let us consider a function f of x is equal to 2x plus 1. If we put f of 1, x is equal to 1, so 2 into 1 plus 1 we get 3. If we put x is equal to 2, f of 2 is equal to 2 into 2 plus 3, answer is 7. If we put f of 3, the answer is 3 into 2 plus 1, we get here 5. The answer will be 7. As we know that all possible values of the x are called domain of the function. All possible input values is equal to domain of function, and all possible output values is range of the function. If we draw two sets, domain and range, the domains are 1, 2 and 3, and for these domain we have range or output values 3, 5 and 7. For 1 the image is 3, for 2 the image is 5, and for 3 image is 7. For this function f, for 1 the image is 3, for 2 image is 5, and for 3 image is 7. आप देख सकते हैं कि यहाँ पर हमने डिफरेंट वैल्यूज़ x की पुट की हैं. x is a independent variable and as a result we get different values for dependent variable, that is range. For x is equal to 1 we get 3, for x is equal to 2 we get 5, and for x is equal to 3 we get 7. In similar way we can put any real number value. The all possible input values, that is 1, 2, 3, is the domain of a function, and all possible output values is range of the function. And here is the arrow diagram. For 1 image is 3, for 2 image is 5, and for 3 image is 7. Is there any way to get 1 from 3, to get 5 from 2, to get 3 from 7? Is there any way to get back 3 to 1, 5 to 2 and 7 to 3? The way to get back from 3 to 1, 5 to 2 and 7 to 3, there is another function that is called inverse of this function. By inverse of function we get the values back, that is from 3 to 1, 5 to 2 and 7 to 3. This new function is called inverse of the given function. So in inverse of function, the domain of the function becomes range of the function, and the range of the function becomes domain of the function. Here you can see in this arrow diagram the domain of function are 1, 2, 3, and for each value we have one image in this set. That is, for 1 the image is 3, for 2 image is 5, for 3 image is 7. For our original function, these are our domain and these are our range. But for inverse, the process is reverse. The domain of the function becomes range of the inverse function. Now you can see in this value the range of the function is 3, 5, 7, but in reverse process we get inverse of the function, and for inverse of the function the range of the function become domain of the inverse function. That is 7 is a domain of inverse function, 7, 5, 3 is the domain of inverse function, and 3, 2, 1 is the range of the inverse function, and that the process is reverse. These red line shows inverse function, and these are the domain of the inverse function, and these are the range of the inverse function. So if we write this function as f of f is equal to 1, 3, 2, 5 and 3, 7, what will be inverse of the function? The inverse of the function is 3, 1, just interchange domain and range, 5, 2 and 7, 3. So such type of function is called inverse of the function. Then we have definition of inverse function. Let f of x be a one-to-one from x onto y. Let f of x be a function. Let f of x be a function. One-to-one from x onto y. That is f domain of x. X is a function of from x onto y. The inverse of the function is denoted by f inverse 1. It is not power minus 1. It is a symbol of inverse function. It is a function from y onto x. That is, inverse is a function from y onto x. That domain and range are interchanged. There are two basic conditions for inverse of the function. That is, the function must be one-to-one and onto. If it is not one-to-one or onto, then their inverse will not exist. You can see in this example, it is one-to-one and onto function, as one is image of 1 is A, image of 2 is B, image of 3 is C, and there is one-to-one mapping, one-to-one correspondence. Therefore it is a one-to-one and onto function, and it is called bijective function. It is called bijective function. That is why its inverse exists. Now what will be its inverse? For its inverse, the arrow diagram will be A, B, C, 1, 2, 3. That is arrow diagram for its inverse. You can see domain of the function becomes range of the function, and range of the function become domain of the function in case of inverse. And you can see, as it is a bijective function, so its inverse exists. Now in this example you can see it is a function. For 1 there is image A, for 2 there is image B, image A, and for 3 there is image B. So it is function. But for this function, as there is not a unique mapping, it is not one-to-one mapping, so you can see if we change it in this way for inverse, you can see it is not a inverse function. It is not a function because there is two different values for one domain. So it is against the definition of function. So it means the inverse of this function does not exist. Inverse of function f of f inverse does not exist. As you can see, there is two different values for one domain, so it is against the definition of function. As you can see, it is not one-to-one mapping, that is why its inverse does not exist. In this example you can see for function f we have for function f we have domain 1, 2 and 3 and range are a, b, c and d. You can see for 1 we have image b, for 2 we have image c and for 3 we have image d. It is 1-to-1 mapping, but it is not onto, as there is no domain for this value a. But now if you apply the definition of inverse function, you can see for if we interchange domain and range, I told you earlier that what happened in inverse function, the domain and range are interchanged. Now you can see the explanation. You can see here there is no image for a. For b there is image 1, for c there is image 2, for d there is image 3, but there is no image for a, and that is against the definition of function. And as it is 1-to-1 mapping but not onto, that is why the inverse of this function does not exist. Inverse does not exist. From these two examples you can see that for inverse it is compulsory that your function should be 1-to-1 and onto, and a 1-to-1 and onto function is called bijective function. If there is bijective function, then its inverse will exist, otherwise there is no inverse. And as I explain you in two examples. So in this example you can see inverse does not exist, as here is the explanation, because there is no image for a in this range. So it is 1-to-1 but not onto. That is why inverse of this function does not exist. So it is necessary for inverse function that the given function must be 1-to-1 and onto. Now here in this last example you can see it is 1-to-1 and onto. You can see there is not one-to-many. For 1 there is image a, for 2 there is image b, for 3 there is image c. So both conditions are verified. It is 1-to-1 as well onto function. That is why its inverse exists. You can see for a there is image 1, for b there is image 2 and for c there is image c. So for inverse of the function, it is compulsory that the given function should be 1-to-1 and onto. And what happens in inverse of the function? The domain and range of the function interchange. The domain value of the function becomes range values of the inverse function, and range values of the inverse function becomes domain values of the inverse function. Now we're going to solve few questions from exercise 1.2, question number 2, so you can get the concept of inverse more clearly.